For decades, the moon has been a distant dream, a place we visited but never called home. But now, that is about to change. We're not just going back. We're building a city, a permanent home on the lunar surface by 2040, powered by water and built with the very dust we land on. This isn't just about planting a flag. It's about building a future, a stepping stone to the stars. The journey to a new world is just beginning. The dream becomes a plan. For decades, the idea of a permanent human settlement on the moon was nothing but a dream, a staple of science fiction, a distant what if. We saw the Apollo missions, watched as astronauts took their first steps, but then we left. For over 50 years, the moon has remained a pristine, desolate, and untouched world. But now, all of that is about to change. The Earth is our cradle, but humanity is growing up. NASA, along with its international partners, is no longer just planning a return. They are building a new future. A future where we don't just visit the moon, but we live there. By the year 2040, the goal is to have a bustling, self-sustaining city on the lunar surface. This isn't just about planting a flag. It's about building a foundation for humanity's future in the cosmos. But how exactly do you build a city on a world with no air, no atmosphere, and no easy way to get materials there? It all starts with a strategic plan and a radical shift in thinking. The Artemis program, a new era of exploration. This ambitious project is all part of the Artemis program. While Apollo was a series of short sprints, Artemis is a marathon. It's a multi-phase initiative designed to build up the necessary infrastructure to stay on the moon for good. It began with Artemis 1, an uncrewed test flight that proved the power of the new Space Launch System, or SLS, the most powerful rocket ever built. Now, we are looking ahead to Artemis 2, which will carry a crew around the moon, preparing them for the next giant leap. Then comes Artemis 3, which will finally put a human footprint on the moon again. This time, landing the first woman and the first person of color on the lunar surface. But the real key to the entire operation isn't on the surface, but in orbit. NASA is building the Lunar Gateway, a small space station that will serve as a science lab and a crucial way station for missions to and from the moon. It's the ultimate refueling depot and command center, orbiting the moon, ready to support the Artemis base camp below. Speaking of the base camp, the chosen location is the moon's south pole. This isn't just a random spot, it's a gold mine. The craters there are perpetually shadowed, meaning they've been in a deep freeze for billions of years. This is where scientists believe there are vast reserves of water ice, and water is the single most valuable resource in space. It's not just for drinking. It can be split into hydrogen and oxygen to be used as rocket fuel and breathable air. Living off the land, the lunar regolith solution. Building a city on Earth is a logistical challenge. Building one on the moon is a logistical nightmare. Each pound of material sent from Earth costs thousands of dollars. So, the only way to do it is to use what's already there. This is where the concept of in situ resource utilization, or ISRU, comes in. It's a fancy term for living off the land, and it's the core of NASA's lunar city plan. The moon's surface is covered in a fine grey dust called regolith. It's abrasive, sticky, and clings to everything. But for engineers, it's also the perfect raw material. NASA is developing colossal, automated 3D printers that will use powerful lasers or concentrated solar energy to melt and fuse the regolith into solid bricks and structures. Think of a construction crew of robots, tirelessly building habitats and landing pads out of the ground itself. These 3D printed structures won't just be for show. They will be the first line of defense. They will be designed with thick, reinforced walls to provide crucial shielding from the two biggest threats on the moon: radiation from the sun and cosmic rays, and the constant barrage of micrometeoroids that pepper the surface. The challenges of a second home. Building a lunar city is more than just a matter of materials. It's a matter of survival. The moon is a harsh environment. One of the biggest dangers is radiation. On Earth, our magnetic field and atmosphere protect us, but the moon has neither. Astronauts on the moon will need habitats with thick walls and even seek shelter in natural lava tubes, underground tunnels created by ancient volcanic activity, that offer natural protection from the harsh environment above. Then there's the lunar night. The moon rotates very slowly, so one full day on the moon is about 29.5 Earth days long. That means 2 weeks of blistering sunlight followed by 2 weeks of total darkness and extreme cold. To power the city, NASA is looking at small, compact nuclear fission reactors that can provide a continuous energy supply, regardless of whether the sun is shining. And we can't forget the dust. Lunar regolith is as fine as flour, but as sharp as glass because there's no wind to smooth its edges. It can damage equipment, tear spacesuits, and pose a health risk to the astronauts if they inhale it. Solving the dust problem is one of the most critical challenges to making the moon a livable place. Researchers are working on everything from magnetic shields to special coatings to keep the dust out, a stepping stone to the cosmos. The lunar city won't just be a place to live, it will be an economic and scientific hub. The moon is rich in resources that could be invaluable for future space travel, including rare Earth elements and a potential fuel source called helium-3, which some believe could be the key to clean nuclear fusion on Earth. Building a city on the moon also serves a greater purpose. It's a training ground for our ultimate destination, Mars. The moon is just a 3-day journey away, allowing us to test technologies and train astronauts for the much longer, more dangerous 2-year trip to the Red Planet. The skills we learn from building, powering, and living on the moon will be directly applicable to colonizing Mars. The Moon City will also become the perfect location for astronomical observatories. With no atmosphere to distort light, a telescope on the far side of the moon could see deeper into the universe than anything we have on Earth, opening up a new window to the cosmos. Imagine a time when the Earthrise is a daily spectacle for those living in the lunar South Pole. A time when a job interview means moving to a permanent outpost on another celestial body. The Artemis base camp is more than just a collection of habitats. It's a living laboratory, a new civilization, and the definitive proof that humans are no longer bound by gravity. It will redefine what it means to be a spacefaring species, transforming our relationship with the cosmos forever. The lunar city is coming. The blueprints are drawn, the robots are warming up, and soon we will make our home among the stars. Conclusion. The idea of building a city on the moon is a testament to human ingenuity. It's an act of faith in our ability to overcome the greatest of challenges. This isn't just a mission for NASA or the US. It's a global effort. We're building not just for our generation, but for generations to come. When you look up at the moon at night, it will no longer be a distant, lifeless rock. It will be our future home, a place of second chances, and the next great chapter in the human story. We're on the cusp of something extraordinary, and the journey to a new world is just beginning.